Hello, hi. So, by popular request, I'm going to attempt to live code. Issue with this is I'm a very slow coder, so I'll try to keep it lively, but we'll see how we go. So, in the last video, we had drawing going, and the way we kind of did this is we did our stuff, we draw the frame, and then we wait for the device to idle before we start the next frame. But this is kind of wasting power, right? Because we have a graphics card with heaps of cores, so if I run this right now, then yeah, it runs, but we see the usage here is quite low. Well, of course it's a CPU, so it's not going to have much usage. Okay, forget what I said. Point is, this is a little bit dodgy. There is a better way we can do this. And the concept is, well, if we've got two operations, one is rendering to a frame and the other one is presenting that frame on the screen, well then the computer can kind of be doing two things at once. So this concept is called frames in flight, or working on several frames at the same time. So let's define we're going to work with two frames at once. And in order to do this, we are going to have not just one semaphore, but basically, in this instance, two semaphores. So down below, we will make this into a list. Okay, so we'll just go down to the code where we create those semaphores. And the first thing we will do is, I'm trying to make this as general as possible. Okay, I've said we've got two frames in flight, but it could be expanded to any number at all. So let's make this nice and general. Okay, so we're going to reserve those two, in this case, hold two semaphores each, but this is completely general. The semaphore create info is perfectly good. Now let's loop through here. So we're going to go So I think I've mentioned this before, and I think this, if you're watching this, hopefully this makes sense. Array objects don't use integers. They kind of use unsigned 64-bit integers, and the shortcut for that is size t, so that's why I'm using size t here. I'm going to have to go... Okay, that looks good. So now let's go and alter our drawing stuff. Oh, I forgot this. Okay, so we've got two frames we're going to be working on at once. So we need to keep track of which frame we're working on at each point. Okay, maybe before we do the drawing, we'll just clean up. Yeah. Okay. Oh, this shouldn't be, I've got the type wrong here. This should be a size t because we're going to use it to index into an array. We don't want to be mucking around with casting things around. Okay. So if I can find draw frame. Okay, cool. So what we're doing is, let's say, for instance, we start and we want to work on frame index 0. So we do all the operations as if it was on frame index 0. And then while that's going, we jump into the next iteration of this, and we want to work on frame index 1. So this will all be based on frame number 1. Okay, that's cool. So then what we need to do is we need to increment the current frame that we're working on. Why can't I type current frame? I don't know. Okay. In theory, this works. Okay, so we'll run this and have a look at it. Cool. So there we have it. And if we check on the side, well, this is embarrassing. So the idea is this is not supposed to fix the problem. Perhaps just with my setup with OBS Studio running at the same time, it's just synchronizing it just right, but this is not supposed to be happening. Two things are meant to be happening. The memory is meant to be blowing out over here on the side. We're meant to be getting a lot of error warnings here. The reason for that, yeah, no, it's not giving any errors. It should be. Okay. The reason this is okay, but it doesn't solve the problem, is that the synchronization between the CPU and the GPU is not quite working. So it's possible, in some cases, not today, but it's possible that the CPU will start repeatedly committing the same object to be drawn, even though that object is tied up in system resources. So for this, we need a different type of structure called a fence. So remember, I talked last session about a semaphore. Semaphore is like a flag. Any thread can see the flag and try to access the resources. A fence is within the same thread. So if you imagine a stream of data from the CPU to the GPU, a fence kind of sits in the way and blocks that from progressing. So let's pop up to the beginning and we'll create a list of fences. Okay, cool. So a fence and a semaphore, they're both different types of synchronization objects. Let's create them in the same function. So we'll go down here, and instead of create semaphores, we'll change the name of that to synchronization objects. Hey, wait a second. Just give me 1 second. Of course it's not going to blow out the memory because I need to get rid of this. Okay. Right, so let's try that again. Oh no, what's happening? Why is it not working? Oh, okay, that's right. And if we look at the thing over here, what does it say? Validation error. Object 0, object type device. Cannot call. Okay, no, I'm looking at the wrong thing. So the reason these errors are coming up is because I'm basically destroying the program before it's all done. But if we look here, validation layer, the command buffer is already in use and not marked for simultaneous use. So that is the CPU grabbing the same command buffer and trying to commit it. It's not good. So that is, and we can fix that error at the end. Okay, right. So where were we? We were creating these synchronization objects. And how many in-flight fences do we want? We want the want to have the same number as we have frames in flight. Okay, so we've got our semaphore create info. We'll make okay, so we're creating fence info, and there's one more thing we need to do. We need to indicate that this fence starts in the signaled state. So a signaled fence pretty much is it's good to go. Right. Now what we need to do is, as well as creating our two semaphores, we need to create the fence. We have device, the create info, the allocator, we're not going to use that, and a pointer to the fence. So we've got that. We then also need to clean this up. Right, so then the question is, how do we use this in drawing? Okay, so what do we have? Well, we have this submit graphics queue, and there's an optional pointer for a fence. Let's pass in the fence for the current frame. So that will be signaled once once the render is complete. Okay, edit this part. So what do we do? Well, the first thing we do is we reset the fence for the current frame. So that takes out device. We are resetting one fence. Alright, so we reset our fence and then we draw, and that is bound to the fence. And another thing we need to do at the start is we need to wait for our current fence. Okay, so what are we doing? We have our device, our fence count, we're just waiting on one fence. The pointer to the fence we're waiting for. This next one, wait all, is, well, if we're waiting for like 10 different fences and wait all is true, then this will not pass until all 10 fences are cleared. In this case, we're only passing in one, so it really doesn't matter what we put here, but just to be safe. And then this has a timeout in nanoseconds, so we disable that by passing in that one, that number. Okay, cool. So let me go through this again. Let's say we're rendering frame 0 and we haven't done anything yet. So we start in frame 0. That fence should be signaled, so it should be okay. We shouldn't be waiting on anything. Then we go ahead, grab that, set everything up. We submit it for drawing. we reset the fence. So in other words, we set it to a non-signal bit, and then once this queue once the graphics queue finishes, that fence is set to signaled again. So this will be, ready to go. So then if we do this and then object 0 is being worked on, but because of multi-threading we get back to this line before object 0 is done, and then if we do heaps of clock cycles and we happen to get to object 0 while it's still being rendered, so this in-flight fences has not been reset, well then this will block and it will just wait for frame 0 to be free again, and then it will continue. It won't matter, right? Because we'll go through frame 0, submit it, rendering. That increments, so we go to frame 1, go to grab that. Well, that's fine, so we can render frame 1 while frame 0 is still rendering. And do you know what I mean? We're making use of spare clock cycles. So if we run this at the moment, this should work. Let's find out. Okay, it's rendering. We're getting no errors. We don't seem to be getting a memory leak. It's not blowing up. That's great. Okay, cool. There's just one more thing we need to do, and that is, okay, this is great. Let's work with 2s. Okay, so let's say we have got 2 images on our swap chain, 2 semaphores, like 2 frames in flight that we're working with. That's great, it'll work. What if we have 4 frames in flight? Like we have some crazy intense graphics card which can handle 4 render passes at once. Well, we render frame 0, frame 1, then we come to render frame 2. It might grab something which is already working, right? So just to cover ourselves, let's keep track of which, if this makes sense, which frame or which fence is working on which image at any point. So we'll go back to the top and we'll make another vector. Okay, and we'll create that in the synchronization objects. Okay, let me explain my intention here. So I've resized it to match the number of images in our swap chain, and I've set it to null because, okay, for an entry to correspond to null, that means the image is free, it's ready to go. When we render something, we set its corresponding image in flight to a reference to the fence which is working on it. A fence which represents the graphics render pass which is working on the image. Does that make sense? We'll see. Okay, so we grab the image, but then the next thing we want to check is if the image is free, or rather if the image is not free. So if we're not free, we wait, and then, because we've grabbed the image, we're going to start working with it. We set the reference, so we say okay, set the corresponding entry for that frame to the fence, which is now going to work with it for the render pass. Okay, so I've checked everything over. I think this should be fine. Let's just double check this. So we'll run it right now. Seems to work fine. Let's see if we can simulate a really bad situation. I'm just going to double check that this is doing something. Okay, let's make this insane. So we're going to render 16 frames at once. That sounds like fun. And yeah, that's not good. It's really not good. Okay, but if we go down here, then it seems to be working with it fine. Awesome. That's mad. That's fun. You know what? Coding live is a lot of fun. Okay, so that'll be it for today. We just had a look at some basic concepts for multi-threaded rendering. I know it's maybe not as exciting as we thought. I always thought multi-threading was going to be really exciting. Turns out multi-threading is a massive headache and it's just stopping things from failing, if that makes sense. But cool. Alright, have fun, and I'll see you next time. Bye.